Welcome to classwork 7.3, textbook section 5.3. Today we're going to cover the double angle formulas. And luckily you already proved them in our classwork last class. All you really have to do is think of sine 2 theta as theta plus theta, and then you can check your notes for last class. But ultimately it becomes 2 sine theta cosine theta. Cosine 2 theta becomes cosine squared theta minus sine squared theta. Now, what's interesting about the cosine one is that there are actually two more. There's 1 minus 2 sine squared theta, and that comes from imagining that, let's change this cosine squared theta. Let's make that into 1 minus sine squared using our Pythagorean, and notice how that becomes 1 minus 2 sine squared. Or we can say, well, let's make this sine squared 1 minus cosine squared in the quantity, meaning parentheses. And notice how if we do that, we get a third one. We get 2 cosine squared theta minus 1. So cosine has 3 formulas, and I do expect you to know all 3. You will be tested on them. But the main one to know is just this one, because just this one, you can easily derive the other 2. So some people like to memorize all of it, but as long as you know that main one, you're okay. And tan 2 theta, same thing. Just do your tan theta plus theta with the sum formula, and you get 2 tan theta over 1 minus tan squared theta. Okay, so I'll put a box around these. Make sure you know these formulas. And that's what we're going to do today. So first example, if sine theta is 5 over 13 and theta lies in quadrant 2, find the exact value of each of the following. So first thing is, notice this thing right here, this thing right here. Let's highlight that. Sine theta is 5 over 13. Theta lies in quadrant 2. So I'm going to draw my triangle here. If it's quadrant 2, let's sketch a triangle there. There's our theta. We know this is 5, 13, so it must be 12. And notice I put negative because that's the x component in quadrant 2. And from here, it's pretty much the same thing we did last class. Just apply the formulas. 2 sine theta cosine theta. So 2 sine theta is 5 over 13. Cosine theta is negative 12 over 13. Let's multiply that. So negative 120 over 169. And there's our answer. Cosine 2 theta. So you can pick any of the 3. I'm just going to pick the standard one. Cosine squared minus sine squared. I like this one. So the cosine value is negative 12 over 13. We're going to square it. Minus the sine value is 5 over 13. We're going to square it. So that's 144 over 169 minus 25 over 169. So the answer must be 119 over 169. Let's put a box around that. And we're good. Tan 2 theta, last one. So we can just use a formula here. 2 tan theta over 1 minus tan squared theta. So we're going to write 2 times negative 5 over 12, all divided by 1 minus negative 5 over 12 squared. And I want to make sure you guys highlight this. Make sure you handle this part first. So really make a note, do first. I don't want you to get messed up with that negative on the outside. So on the bottom, leave that as 1 minus. Let's square that. That's 25 over 144. Now work with the top. That's going to be, I'm just going to multiply it straight. So that's negative 10 over 12. Now it's multiplied by our common denominator, which is 144 over 144. Now we reduce. Negative 120 over, look at that, 119. And again, that comes from just distributing. So you distribute that there, that becomes 12. Distribute that here, that becomes 144, and that becomes 25 once you distribute that. Now you could do this next level thing where you just divide part A and B. On your homework, feel free to do that as well. You do that, you also get the answer. That's also really fast. Hey, example 2. These are going to be your classic, put a big star here, reverse problems, meaning you figure out what identity we're talking about and then apply it in reverse. So this one's clearly the tan 2 theta formula. Let's erase that theta and let's plug in the angle, which is 15. That's going to be tan of 30, and we know tan of 30. That's the root of 3 over 3. Now this one, this is clearly your cosine 2 theta formula. So a cosine 2 times 15, it's cosine 30, and again we know that. That is root 3 over 2. So those are pretty nice, really, really cool questions. Now here's going to be our identity for the day. This one's a tough one. So it looks like you want to pick the right, but in reality you actually want to pick the left, even though there's a lot less to work with. The reason for that is because that cosine cube, there's not a lot you can do with that. And it's going to be easier to break down cosine 3 theta than to somehow end up at cosine 3 theta. Again, it is possible to go from right to left, but this is going to be a lot easier. So make sure you pick the left. The thing you have to do is you split it like this, 2 theta plus theta. So similar to your theta plus theta trick you did to derive these formulas. By doing this, let's apply our sum formula now. That's cosine 2 theta, cosine theta, so cosine A, cosine B. The sign should switch, minus sine A, sine B. Now apply the formulas again. So notice how everything's in cosine. So I'm going to change cosine 2 theta to the cosine version, which is 2 cosine squared theta minus 1 cosine theta. Sine 2 theta is 2, sorry, let me erase that, 2 sine theta cosine theta, and there's one more sine theta. Now let's distribute this. So we have 2 cosine cube theta. That's a good sign. There's a cosine cube there. Minus cosine theta. And then minus, let's combine that, 2 sine squared cosine. Now, we're getting pretty close. If you look at this, the only weird part is right there, this sine squared. This thing I'm highlighting. So we got to figure out, well, how do you change that? And the way you change that is, again, using your Pythagorean identity. That's going to be 1 minus cosine squared cosine, like that. Now, a lot of people have a hard time multiplying this, so this is what we're going to do. I'm going to grab this thing, move it there. So basically just rearrange it, and notice how this is going to be a lot easier to think about now. Now multiplying it seems a lot simpler. We're going to write 2 cosine cube theta minus cosine theta minus 2 cosine theta plus 2 cosine cube theta. And hopefully we're there. 4 cosine cube theta minus 3 cosine theta. And look at that. We just proved it. Done.